Next one says, which compound is a secondary amide? Now, before you work out the answer to this question, you have to figure out what do we mean by amide. Amide is a compound that has this functional group in it. So if I look at the first one, this can't be amide. It is amine. If I look at the second one again, this can't be amide. Doesn't have that functional group. Now there are only two options, option one and option two. What did you go for?
I went for C.
You went for C. It is secondary because the third one is
Tertiary.
tertiary. This is third degree. This is second degree, right? So the answer will be C. Next question, question 3. It says, which compound does not react with nucleophiles? Nucleophiles are electron donors, right? Or I can say they have lone pair of electron which can be donated. Now, if I look at the first one, this contains CHO group. So if it contains CHO group, that's C double bond O dash H. I can see this is delta positive, so it will be exposed to nucleophiles. So this will react, right? Next one is CH3, CH2. So if I look at this one, this is an alkene, 1, 2, double bond this. And that. So again, if it is alkene, will it react with nucleophiles?
Yeah.
It won't react with nucleophile because this is electron rich region. So if a nucleophile tries to come close to it, it will be repelled by it. So the answer is B. Next question says, which structure represents an alicyclic compound? Now we never did this part, so can I please ask you to copy this quickly? It will be a cyclic compound which has no alternate single or double bonds. It's a cyclic compound which will not have any alternate single or double bond. So I can see here you've got alternate single and double bond. So this can't be the answer. In this case, also you have double single, double single, double single alternate. So this can't be the answer. But in this case, it is not the case. Do you have double single, double consistently? No. So the answer is C for this question. In this case, we don't have this single or double bonds. It's a benzene ring. Now I've done first 4 questions from here. What I would like to do now is I want to move on and I want to follow the same approach. So rather than starting from the first question, because the first questions are always easier, we'll start working from the last question and then we'll move backwards. Right? Let's start with this question number 22 first. The relative molecular masses of boiling points of some fuels are shown in figure 22.1. So they've given you the relative molecular masses and they've given you boiling points, and then they've given you the names of the 3. It says write an incomplete combustion of heptane. Now what happens in incomplete combustion? Incomplete combustion means it should produce CO and H2O. This is what will be produced in this case. So I can now say it talks about heptane. How many carbons will I have in heptane?
7 carbons.
C7. So what will be the formula?
H14.
H14. H16 plus O2 will give you CO plus H2O. You have to balance it. There are 7 carbons. There will be 7 CO. There are 16 hydrogens. It will be 8 H2O. Now 8 oxygens here, 7 here. In total, I have 15. So I'll multiply this by 7 point. Next question is fairly easy. It says, explain the difference in boiling points of fuels in table 22.1. So I can see here, BP, which one is the biggest? Pentane 1-ol, followed by heptane, followed by hexane. Now for pentane 1-ol, I can talk about, so they are all simple molecular structures. So all of them will have intermolecular forces of attraction, but there are different types of intermolecular forces of attraction. In this case, I'll say H bonds between molecules. Okay, number 1. Number 2, I can say it is the strongest IMF. Therefore, BP is high. When it comes to hexane, I'll say it has only VDW, which is van der Waals forces. These are, number one, they are weakest. Okay, we have to say between molecules. They are weakest. Again, in this case, I'll say the same thing. Has only VDW between molecules. That's one. Now I have to do a comparison between them two. Why is it that this one has also got VDW, but this one and this one, but this one has a higher boiling point than this?
And it has more points of contact.
We can say that,
Electrons.
but we can say because it's a bigger molecule. We can say it's bigger molecule has more electrons, number one. Okay, number two, we can say more surface area contacts between molecules. Next question. Says fuel additives are often used to improve the combustion of a fuel. Compound N is a fuel additive containing carbon, hydrogen, and oxygen only. I can say N has CX, HY, and OZ. Complete combustion of 1.71 grams of compound N produces. So I have N. When you burn N with oxygen, it will produce CO2 and H2O. It says I used only 1.71 grams, and this produced 2.97 grams of this and 1.62 grams of water. They've given us the relative molecular mass of compound N is 76. These are my masses. I can convert them into moles. If I convert them into moles, what will I do? I'll divide the top number because I've been given the MR of this one as 76. So I can divide this by 76. I can divide this one by 44. I can divide this one by 80. And if you divide them, you will end up with answers 1.71 divided by 76. That gives me 0.0225. I do 2.97 divided by 44. That gives me 0.0675. 1.62 divided by 18 gives me 0.0. Now I can work out the simplest ratio here. If I work out the simplest ratio, I can see out of these, this is the smallest one. So I can say 1 mole of this divided by 2.0.025. That gives me 4. And 0.0675 divided by 0.3. So I can now go back to my equation. I can go back to my equation and I can say this will go there, 4. This will go there. That's 4. This is 3. It will produce 3, and this will produce 4 moles. Now what will happen in this case is I can then say this will go at this location. But I'm now going to replace N with, this N with CX, HY, OZ. How many carbons are there? 3. So I can say X has a value of 3. How many hydrogens do I have in total? 8. So Y has a value of 8. Now this is done. This is done. To work out the oxygen, what I'll need to do is I'll have to do, because I was given the MR, which was 76. So to work out the oxygens, I'll do 78 take away 3 times 12 plus 8 times 1. What do I get if I do that? What do I get? Mohan?
You get around 34. I might have done that right.
Okay, sorry, that's a bit, something went wrong here again, right? This is not 78, this is 76. That's what I was thinking, right? So if you do that, you'll end up with 32. Now 32 is same as what? 2. So I can say Z will be equal to 2. Because if I divide this by 16, it will give me 2. And this is the value of Z. So my formula will be C3, H8, and O2. Let's move on to the next bit.
So do you have to draw a compound?
No, it doesn't say that. It just says calculate the molecular formula and suggest a possible structure of compound P. P3H8. Now we can, in this case, because it contains O2, so we can draw any structure as long as it has 3 carbons. So I can say 1, 2, 3 carbons. How many oxygens are there? 2. Can I have it as CnH2n plus 1 COOH? If I take carbon out, 2 oxygen and 1 hydrogen, then I'll be left with C2H7 and C2H7. They are not the same, so we can't have carboxylic acid, right? Let's change it to, how many hydrogens are there? 1, 2, 3, 4, 5, 6, 7, 8.
Would you make it into a di?
We
A
can
di
have
alcohol.
OH
Di-OH.
and H. Should be fine. Let's move on to the next part. Okay, both of you who are attending class online, if I'm going fast, you need to stop me. Says Solcatel has been investigated as potential fuel additive, and this is synthesized from propane 1,2,3-triol and a carbonyl compound. So they are saying here propane 1,3-triol and carbonyl compound. These two, when react together, they'll form this. Construct a balance equation for this synthesis. Show structures for the organic compounds in your equation. I can put a carbon here, I can put a carbon here, I can put a carbon here, I can put one carbon, another carbon, and another carbon. Agreed? Now in this case, I can see something has happened. It says triol means, if I look at it, this is carbon 1, this is carbon 2, this is carbon 3. So I can say this is 1, 2, 3. So if I break it from here, then the left side will become, what will it become? It will become propane 1,3-triol. So I can draw that and I can say 1, 2, 3. And if you look at the right side, it has to be a carbonyl compound. So you have C-C. On this one, you've got 3 carbons. Can this be an aldehyde? It can't be an aldehyde, because if it was an aldehyde, then the C-OH should be on the end, right? C double bond O and H should be on the end. In this case, I can say the only option for the carbonyl compound will be to have a ketone. Next question is an important one. Again, it's a 6 marker. What they are asking us to do in this case is they're asking us to work out the structure. We've been given some information, and the question asks us, because I didn't print out the last page, says use the information provided, the structure of compound. So we have to use this information to suggest structure of compound. Let's have a look. Now, they've given us two pieces of information here. We've been given something here as elemental analysis. Why do we need this elemental analysis? Because if I use empirical formula method here, I can work out the molecular formula. Empirical formula plus this information can be used to work out the molecular formula. What I'll do is, first of all, part A, D, I'll do here carbon, hydrogen, and oxygen. Masses, we can say mass is 54.54, hydrogen is 9.10, oxygen is 36.36. I can convert them into moles by dividing them with their respective AR values. So if you divide 54.54 divided by 12, you'll end up with 4.545. This will be 9.10, and 36.36 divided by 16 will give you 2.2725. Okay, so if you divide them all, now simplest ratio, this will be 1. This is 4, and 4.454 divided by 2. This is 2. So I've got the formula. Empirical formula is C2H4O. What's the MR of this? If you work out the MR, you'll end up with 12 times 2 plus 4 plus 16, which is 44. Now, what we've been given here is we've been given the mass spectrum. Molecular ion peak is at M/Z ratio 132. So this is my molecular MR of the, what is that equal to? That's 132. This is given the question. How will I go from 42 to 132? I'll have to multiply it by 3. I can do the same thing over here. I can multiply it by 3. It will change to C6H14, no, 12O3. Done? Okay. Now what we've been given is we've been given some information on this diagram here. Now this is our 1H and MR. So if I look at this data, it gives me some information. This is number one. Number one means it only has one hydrogen. So there's only one hydrogen, and next to this hydrogen, I won't say next to this hydrogen, on the carbon atom, which is next to the carbon atom containing this hydrogen, there are 3 hydrogens on it. There are 3 hydrogens because it's a quartet. So next, C atom has 3 hydrogens in different environments. So I'm going to make a note from this to, we can say, I'm going to say here, next C atom has 3 hydrogens. Remember, they are in different environment. Here, these are now 6 hydrogens because that's the number integration ratio. 6 hydrogens means in this case, the next to, I'm going to say next C atom has no hydrogen. That's why it's a singlet. And I look at the next one, says there are 3 hydrogens are in which type of environment? Again, I'm going to say next C atom has 2 hydrogens because it's a triplet, no, single. One H. It's a doublet, right? So it should be, the rule is n plus 1. The rule is n plus 1. If you read further information, it tells us something more, and we will look at it in a minute. First, let's have a look at this section only and see what can we devise from this. You will be given this sheet in exam. You all will have a copy of this. Those who are sitting in my class now, they already have a copy of this. So we can see here, first one, this is at number, location number 4. So we are looking at this bottom one. Where is 4? 4 is here. So it tells me that I have something like that. This carbon has a hydrogen, and this carbon is bonded to oxygen. Okay, number 1. So I can say for this section, I can say this is what it says, O, and it has a hydrogen. But it tells me something more, that on the next carbon atom, there are 3 hydrogens. There are 3 hydrogens. So I can say, I can draw another carbon next to it, and this will have how many? Are we happy with that bit? If I look at this section here, it says this is at 1.2 and 1.3. This is section here. This is over here. This means they're talking about this is C. This carbon has a hydrogen, and on one side it is R, but there are still 2 more possibilities. We can have anything on those sides. We can say for this section, I can say I'll have a carbon. On this side, I'll have this. Below, I'll have this as well. Agreed? Which one is left now? This one. It says next carbon has 1 hydrogen and this. So I can say this is same for this section. Because look, this will produce a quartet. These 3 will produce, or they produce a doublet. And these 6 will produce a singlet. So I've got 3 things that I can extract from here. Now let's carry on reading the remaining question. Next question says the number of the peaks, the number of peaks are relative peak areas. That's fine. When the spectrum is run without D2O, there are 2 additional peaks with the relative peak areas at 11 and with the same relative peak areas at 11 and 3.6. Now, this is something that we've discussed here. When you mix with D2O, an OH peak will disappear. What will that confirm? I'll confirm presence of O-H. or
H.
N dash H. But let's have a look. It says at 11. At 11 means it doesn't say alcohol, it says O dash H. At 11, what functional group do I have? Carboxylic acid, right? So I can say at 11, it will be COOH. And then I have one at 3.6. What do I have at 3.6? What do I have at 3.6?
HCO.
HCO can't be figured out using this. At the top, what do I have? OH or NH. Now, I can't have NH because I don't have any N in this compound. So this is for OH. So when you're working out the answers, you'll have to do this, right? You will say, you'll have to draw them and you'll say, this will produce, what will it produce? Quartet at 4. These ones will produce doublet at, let's say, 1.3. Okay. Number 2, I can then say these ones will produce what? Singlet at 1 point, let's say, let's make it 3 here and let's make this one 1.2. Then we also have identified there is also O-H. Yes, Kazan.
So why is it singlet?
Which one? Because on this carbon atom there are no hydrogens.
Oh, okay.
Okay, because we are assuming there are no hydrogen. I can put 2 lines here, but there is no hydrogen.
Yeah.
Okay, so if there is no hydrogen, then it will be singlet. We now have to add these 2 as well. You have to add them 2. So I now have to give a possible structure. I have to give a possible structure. So I can see if I combine this with this, can I add H next to this section? I can, right? So I can say, when I give my final product, it will look like this dash C dash H dash OH. This is gone now. What am I left with? I'm left with this section. I can then say here, I can have a carbon. On one side, it will have CH3. On the other side, it will have CH3. Okay. Now, what am I left with? I need to add this one. I can add this over here. Now you can see here, again, I can remind you, this will be doublet. This will be quartet. This one will be singlet. And when I say singlet, I'm talking about all of them, right? Okay, 1, 2, 3, 4, 5, 6. And then we had 2 more peaks. Okay, this one disappears with D2O. This one also disappears with D2O. Before I move on, very important question, because it just kind of summarizes everything that you need to know for HNMR. So make sure you know this. If you don't, then you will have some sort of consequence for that. And I don't want any one of you to struggle when you're doing exam. Am I good to move on? Sana, do you have any question?
No, I'm okay. Thank you.
Okay. Mr. Ridwan? Let's get on to question number 21. Any question that appears like that, make sure you first check what kind of functional groups are present. Now, I remember sharing this file with all of you. I've taken it from the specification. Your specification has everything. So these sections, I took them from your spec, and they're very useful while you're doing papers. But when you're doing exams, this will not be given to you. So you'll have to know everything on this sheet. But it kind of summarizes here. On this question, it says this question is about aromatic carboxylic acids and their derivatives. The flow chart below shows some reactions of compound H. In the boxes, throw the organic products of these reactions. I've got alcohol and I've got sodium hydroxide. When I react alcohol and sodium hydroxide, nothing will happen. But the carboxylic acid will react with NaOH to form the salt. So the only thing that will change is this section will change here. So say 1, 2, 3, 4, 5, 6. This location will become C double bond O dash O minus and Na positive. Here you'll still have H. With sodium carbonate, same thing will happen. But the products will be a little bit different. In this case, it will be water in addition to this. In that case, it will be carbon dioxide and water. I'll draw exactly the same thing, nothing different. When I reacted with bromine, now you have to remember that we are looking at this section when it comes to bromine. These two will play a part now. Here it was the highlighted sections. Now in this case, when you have OH, what will happen? You can see here. You can add bromine to OH and the substitution will take place at location 2, 4, and 6. You can choose one. You can add more than one. So in this case, I can say it will then change into I can say BR. Could be at location 2, 4, or 6. If you add BR on this side, it will still be the same thing, nothing different. It will still be on carbon atom number 2. Yes, Sana, go ahead.
So when you react it with bromine, only one of them goes onto the ring, and it's not all three of them.
It can. It's all are possible. You can have one. You can have two of them. You can have three of them as well.
Okay.
Okay, so you can see here they've given 1, 2, 3. But at location number 4, will you be able to replace this? You can't replace this. So in this case, there can only be 1 or 2 substitutions.
Okay.
I can write down here. Or you can also have C double bond O dash OH dash HO. You can have BR and BR. Both are possible. Yes, Sana.
You know the reactions with the carboxylic acid with the NaOH and the Na2CO3.
Yes.
So where would you find that on the map thing from the spec?
Where will you find these ones? Now, I don't think you'll find these somewhere. You just need to remember when it comes to the reactions of carboxylic acid, they'll all be same as the normal acids. The only difference will be these reactions will be slow than the mineral acids like hydrochloric acid or sulfuric acid or nitric acid.
Okay, thank you.
So it's always the H from the carboxylic acid that will be released as H plus ion, and that will then form water. And as a result of this, so I can say here, if I have R dash C double bond O OH, there will be a reversible reaction and it will change to R dash C double bond O O minus plus H positive. Now, this is the ion that is being formed, which is negative. So next to this, to make a salt, which is ionic salt, you'll have to add a positive ion. So you just add any positive. Your example might be another one, K plus. So you just do the same thing. Okay. Next question. This time, what they're doing here is we need to convert. We've been given a compound H, which is this one, and it is being used to make a polymer called I. But before you make this polymer, you have to change this into acyl chloride. You have to change it into acyl chloride, and it says you have to then polymer I and complete the flow chart by drawing the structure of acyl chloride and 2 repeating units of polymer 1 and stating the formula of the reagents required for the first stage on the dotted line. Be very careful because it says 2 repeating units here, and they've mentioned it over there as well. So what we will now do is, again, acyl chloride means I'm not going to do anything to the left side. Only thing I have to do is I have to change this into acyl chloride. So everything will remain the same. The only thing that will change here will be this OH will get replaced by Cl. Now, again, you will find these reactions over here. I've got carboxylic acid and I need to change it into acyl chloride. What's the condition for that? SOCl2. SOCl2. I'll write down SOCl2 on top. Now, this monomer has 2 functional groups. It has 2 functional groups. So this means it can form a polymer. It can form a polymer. So when it comes to, if I have the same one and more than one, then it can form polymer. Okay. I can take 2 of them because it says 2 repeating units. So if I start with the first one, H will be gone from here. Cl will be gone from here because this time the byproduct will be HCl. It will not be water. So I can say the first one here, C double bond O dash O dash so when polymer is formed, this will get removed and H will get removed. If you remove them too, then the same thing will get repeated again and again. And I've done the first one here and the second one. So this is my repeating unit.
So do you draw a bracket around saying 2?
No. Now, what is this one called here? There.
It's ester.
Ester linkage. So I'll call this one, this will be my polyester. This is my example of polyester.
So do you have to say linking the linkage part? Or
No, but I'm just telling you, right? I'm just letting you know in case in exam they may ask you things like that, right? Now the next question is something that I never discussed in class because it's only for the OCR people who need to know. We don't do questions like these on AQA spec. Generally, I have not come across a question like this on. So I want you to put star on this question and make sure you understand this. Who knows? Because it doesn't tell you anything about solving these type of questions on the revision guide as well. So now here it says there is a cosmetic product and it contains 4 esters, J, K, L, and N. And it is analyzed by gas chromatography and mass spectrometry. The results are shown below. So these are the mass spectrometry ones. These are from gas chromatography. Now, given us some information here. So they are saying here that the concentration, and it says the number of the peaks are the relative molecular proportions of the compounds in the mixture. 5.9 portions, 4.3, and 4.2. So the concentration of ester K in the cosmetic product is 9.13 times 10 to the power of minus 2. 9.13 times 10 to the power of minus 2. It also tells us something here, are the relative molar proportions. What does that mean? Bigger moles, bigger amount of portion, bigger will be the concentration. If this value increases, the concentration will increase. If this value decreases, then the concentration will decrease, right? So the concentration basically depends on these values, right? We can say concentration depends on them. Now the question, it says the concentration of ester K in the cosmetic product is 9.13, 10 to the power of -2 grams per dm cube. Can I use concentration in grams per dm cube? Because my final answer has to be mole dm cube. So first of all, what I'll do is I'll do 9.13 times 10 to the power of -2. What's the MR of this? This is K. The MR is 166. So I can divide it by 166, and this will give me 5.5 times 10 to the power of -4 mole per dm cube. That's my concentration. Now I can write down for K. What does it say? K has what value was it? What was the relative molecular proportion? 4.3. So I can say it will be 4.3 produces how much? 5.5 times 10 to the power of -4. Are we happy with that bit? The question says, using the results, calculate the concentration in mole dm cube for ester M. So I'll write down next will be M. How much is M? M has a proportion of 5.9. I'll write down 5.9 will produce concentration of X. Now it's up to you. You can do it in the way you want. What I do is I cross multiply and solve. You can divide them two and equate. This will be equal to divide them two as well. Ratio of them two or fraction this divided by this will be equal to this divided by this. Or you can say you multiply this with that, and then you can solve for X. So if I multiply this with that, it will turn out to be 4.3 times X equals 5.9 times 5.5 times 10 to the power of -4. I can then divide both sides by 4.3 and 4.3. This is gone. Leaves me with X being equal to 7.5 times 10 to the power of -4 mole per dm cube. So you have to make sure you know this method of calculation. Has anyone got any question? Okay. Next part. Says a general structure for ester J, L, and M is shown. J, L, and M, general structure. This means they all will have only one thing different. And what is that? R will be different. Okay, this will be different. It says where R is an alkyl group. Alkyl group means it will be CnH2n plus 1. Use the mass spectrometer results to deduce possible structures for esters L, J, L, and M. So first thing what we need to do is, because from the mass spectrometer, right, what will I do? This will give me the values of MR. It will give me the values of MR. Can we work out the mass of this section? MR equals how much? It will be 137. I'm just giving it to you. You can do it later, right? It is 137. Now, first one, J has what is the, if I go to the previous page and have a look, J has MR of J is 152. MR of L is 180. MR of M is 1802. Okay. Now what I can do is to work out this R, I can do 152, take away 137. What do I get? 15. This is MR of R. This R for this. I can do the same thing here. 180 minus 137 equals 43. This will be the MR of R. I can do the same thing. 180 minus 137 equals 43. This is my MR of, where R is what? So in this case, it is easy. In this case, I can say R will be what? Just CH3. Easy. In this case, things are a little bit complicated. In this case, things are a little bit complicated. So what am I going to do in this case? I'll say, because R was CnH2n plus 1. Look. CnH2n plus 1. So it will become 12n plus 2n plus 1 equals 43. And if I solve it, it will become 14n plus 1 equals 43. You do minus 1, you get n as 3. So this means my formula will be C3H R is that. In this case, also R is C3H7 because I've got the same MR. So for the first one, I can say R will be dash C and then 3 hydrogens. For the second one, I can say R will be dash C dash CH3 dash H dash CH3. Are people with me on that bit? And for this one, I can say R will be just dash C1, 2, 3 and straight chain. So I've got 3 different R's here. Because then, are you with me?
Yeah.
Okay. Any questions so far?
No.
Okay. Then I would like you to move on to question number 20. You try yourself first, only the first part, and then I'll take you guys over in a minute. Yes, Sanam, go ahead.
Could you show the top part of the question?
I did send this paper. You don't have a copy of the paper on you. That's very strange. That's not very good, because if you don't have a copy of paper on you, I don't know how you will cope. What will you do later on?
I couldn't print it out because my printer isn't working, but I've been copying down the questions on paper.
No, it just brings me a bit of extra work, so I'll have to send a copy to you people then. But I am recording the lesson as well, so I'll send you the link later on as well. So if you want to go through it later, you can do that too. Oh, it's
Sir, we do have it.
sorry.
You have sent it.
Have I sent what?
You sent the paper.
I did, but it was not filled in. wasn't it? Was it?
What do you mean?
Like I never, it was not with solutions, right? It was just for printing.
No.
So once I've done the paper, I'll send you the with answers at all my working at.
Okay, sir.
Okay, let's quickly have a look at this question now. This time again, we've been given two compounds, okay, and it says here they naturally occur, they are both naturally occurring, and it says aldehyde, aldehyde. It's not only aldehyde which is present in them. You can see here's one functional group, there's another function, but they also have alkene functional group in them as well. Now it says explain this statement is an E stereoisomer. Now, remember, we have two types, E and Z. When it comes to E, Z is that right, or is it the other way around?
No, it's the other way around.
Huh? No, it's right. Yeah, Z is same side. E is diagonal.
Oh, yes.
What is this? This is high priority groups. This is again high priority groups. Now, what are high priority? What do we mean by word high priority? Suzette?
The ones that have the highest mass.
Bigger M. Bigger, we can say M slash AR, could be others, right? So in this case, it says, in which one are they talking about? They're talking about this one, and they're saying this is E I stereoisomer. Explain this. So if I look at this, I've got C double bond C. On one side, I've got CHO. Here I'll have CH3. Here I'll have H, and here I'll have this whole thing. I'm gonna call this thing R. You happy with that thing? Now, which ones have the bigger MR? CHO or CH3?
No.
CHO. Which one has bigger MR, H or R? R. So in this case, I'll say because high priority groups are on diagonal. Therefore, it is.
So I put my phone on your charger.
Which charger? What?
iPhone.
I don't have iPhone. Mine is the other one.
How charger?
Then I can't help you with that, right? Because I put a Samsung one. If you need Samsung, I can. Do you have a converter on you? Yes, Zain.
So is that all we have to write?
Yes, because it says explain the statement in terms of these rules. So the rule says high priority groups are on diagonal. When they are on diagonal, then this is the case. So you have to mention it because in my case, I'm telling you, I do the diagram, this answer plus this. If you write that down, then you are fine. If not, then you have to mention it very clearly. So you'll say here, this and this, they are both high priority. And that will get you the second mark, right? So you have to identify them as well, otherwise you can't get the second mark. So what do you mean by high priority group? So you have to tell them which groups are high priority groups.
Yeah, okay.
Are we good to move on? If you don't want to write this down, then you can say CHO and C6H5. They are both high priority. That's another way of saying what I do. I use the diagram because I find that more convenient and easier for me rather than writing things like that. Okay, so this is another way of answering. Done. Next question. A student plans to carry out some chemical tests on both of them. Suggest a suitable chemical test to confirm both compounds contain unsaturated carbon chain. Unsaturated carbon chain means C double bond C. What will you do in this case? You'll use B aqueous, Br.
Did you say bromine?
Bromine, or you can say Br2 aqueous.
So could you say bromine water?
That's fine. Describe a chemical test to confirm both compounds contain an aldehyde functional group. You know about the Tollens reagent, right?
Yes, sir. Aren't you supposed to put the observation for the person as well?
Okay, sorry, I never looked at this part. Observation will be, it will change from brown to colorless. Next one is Tollens reagent. Observation will be silver mirror. Now, next question says, this is where I put star for myself. If I have to answer a question like this, I'll struggle, and I'll make sure I go through this question before the exam. It says, describe a chemical test to confirm that both of these aldehydes contain a carbonyl group. How could the products of this be used to distinguish between two compounds? Your answer should not include spectroscopy. You can't talk anything about spectroscopy. So we'll use here 2,4-DNPH. What will this do if you use 2,4-DNPH? It will form deep orange PPT. And this will be for both, right? This will be for aldehyde and ketones. But in this case, we don't have to worry about ketones because the question does not ask us anything about ketones, only about aldehyde. So what will I do in this case? I'll have 2,2,4-DNPH precipitates. All I then do is, number one, I'll say filter and dry PPT. Number three, I'll then perform, what do I do?
You crystallize it.
MP test, melting point test, and compare with data. Data booklet. Understand?
Yes.
Sure. Next page again. Like I said to you, before you do anything, make sure you check what functional groups are present. What functional groups are present. In the first case, what are they doing? They're changing aldehyde into. So when you add aldehyde to cyanide, again, I can go back to this diagram. You can see this is aldehyde. If I want to add CN, if I want to add cyanide to it, then it will be NaCN in the positive H positive acid condition. So I'll write down here sodium cyanide, aqueous, and H positive. Now you have to remember in this case, this result will have, this has two functional groups. So something important to remember, whenever you add cyanide to aldehyde, it will always produce a product with two functional groups, hydroxyl and cyanide. Now here we are using H2 and nickel. We are using H2 and nickel. So what are we going to do? This will be the reduction of nitride. This is for reduction of nitride. So what will happen in this case? It will change to, everything will remain the same. Only one thing will change. 1, 2, 3, dash, dash. Here it will be OH. Here will be C, but I can't put C anymore here. I'll just have to put another this and N and two hydrogens. Can I add hydrogens? Now, when I look at the mark scheme, it says that you can have here at this location, you can change to CH2 and NH3. It's going to be NH3 or NH2Z.
Pretty sure NH2
Why NH2?
is the DL pair.
No, nitrogen can only have 3 bonds around it. Because nitrogen can have only 3 bonds around it. Okay, so it will be NH2. Here, what are we doing? There are two things. This is H plus and aqueous. This is same as H2O in H positive condition. So this is basically hydrolysis. And we learned about this. Whenever you do hydrolysis, then the nitrile group will change into carboxylic acid. It will change into carboxylic acid. The only thing will be same thing again. 1, 2, 3. Dash. Here it will be OH. At this location, it will change to C double bond O and OH. This is my aldehyde, and I'm doing NaBH4. So this is basically reduction again. So when you do reduction of aldehyde, it will change into alcohol. It will change into alcohol. So again, same thing. 1, 2, 3, 4, 5, 6. 1, 2, 3. Dash, dash, dash. This location, I can put C. Here will be OH, H, and H. Okay. Am I good to move on? Next question says, again, you've got this aldehyde and it reacts with iodine, monochloride, ICl, by electrophilic addition. The reaction produces a mixture containing 2 different organic compounds. What did they say? It reacts through electrophilic addition. Electrophilic addition. The reaction produces a mixture of 2 different organic compounds. What kind of reactions do aldehyde those? So if I have this functional group, what kind of reaction will this undergo?
What's the one in the middle? Is that just carbon?
This
What's that?
carbon.
Oh,
Just tell me what kind of reaction will it go? Addition, substitution, what? These are aldehydes. Aldehydes undergo,
addition.
yeah, but do they go electrophilic or nucleophilic? This is nucleophilic addition, right? Nucleophilic additions. So in this case, the question talks about electrophilic addition. So remember, if I look at this, this will undergo nucleophilic addition. The question is talking about electrophilic addition. So electrophilic addition means it will come and play its part at the double bond because this is alkene. This is alkene. So what I'm going to do is I'm going to change this into something else, and I'm going to show you this as C double bond C. Above I have CHO, below I have CH3. At this location I have H, and I'm going to call this thing C6H5. Are we happy with that bit? Okay. Now it says the electronegativity values of chlorine and iodine are given in the table below. So they've given you these two. What does that mean? So this means I and Cl, when they are bonded together, Cl is more electronegative. So this will be delta minus, iodine will be delta plus. Okay, so it's the electrophile, which is I minus, I positive side, that will behave, that will get attached to carbon atom first. Outline the mechanism using curly arrow model for the formation of one of the organic products, and explain which of the 2 possible products is more likely to be formed. So I started with this C double bond C dash CHO. Here I have CH3. Here I have H. Here I have C6H5. Now the 2 products from here will be CHO, CH3, H, C6H5. Now I can say one will have I here and one will have Cl. In the second case, I'll have 1, 2, CH3 dash CHO dash dash C6H5 H, and here you will have Cl here and I here. Now remember, we said it is this that will behave as electrophile. So this will get attached first. As a result of this, I'll say this will get attached first. So as a result of this, what will happen? This carbon will become positive. In this case, this carbon will become positive. Now, if you look at it carefully, this one is secondary carbocation. This one is primary carbocation. Is it primary? Is it tertiary? Okay, second.
I think ICHO CH3 is tertiary.
This is prime. This is secondary. This is secondary or tertiary.
For the CL.
This one, yes, it will be tertiary.
Yes.
And this one will be
Secondary.
secondary. Now, the tertiary carbocation is more stable. If it is more stable, then this means this will be therefore major product. Now I just need to show the mechanism. So in this case, what will happen? C double bond C, 1, 2, 3, 4. I can say I have CHO, I have CH3, I have H, I have C6H5. So electrons will move towards I dash Cl. This is delta minus, this is delta plus. Electrons will go to this. As a result of this, you will then have and here it will be positive. Okay. Then you can have Cl minus, these electrons will move to this, and as a result of this, this will then change into C dash C. Done. Now it does say here, okay, that's fine. This was all about it. I think that's the next part. Was something in my mind, but it's not part of this question. It's on another question. Has anyone got any question before I move on to the next question? Nope. 18. This question is about aromatic compounds. Phenol undergoes nitration more rapidly than benzene. As a student carries out nitration of phenol with dilute nitric acid to produce 2 nitrophenol and 4 nitrophenol. Small amount of 3 nitrophenol is also produced. The student thought that this carbon-13 NMR spectroscopy could be used to distinguish between these 3 nitrophenols. Explain whether the student is correct. We'll have to identify how many peaks each will produce. So in this case, I can see they are all in the different environment. There'll be a peak, 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 and peak. They're all in different environment. Same applies to this one. This one will produce 6 peaks. This one will also produce 6 peaks. Therefore, they can't be distinguished. number 1. How about the next one? Here, I've got 1. This is 2 and 2. They're in the same environment. This is 3 and 3, and this is 4. This one will produce 4. This one can be.
Sir,
Yes.
remember the first one, doesn't it have 5 peaks?
Why will it have 5 peaks?
Because you see where 4 or 5.
Yeah.
Aren't those like the same?
Now look,
Radical?
4 is from NO2 side, 5 is from OH side. Is OH and NO2 the same? Then
Okay.
they are not the same, right? Yes, if it was OH and this was also OH, then it would have been different. Then they both would be same environment. They both will be same environment, and these two will be also be in the same environment. So these two can't be separated, but these two can't be distinguished, but this one can be distinguished. Done. Says explain why phenol is nitrated more readily than benzene. So in case of benzene, we do HNO3 plus H2SO4, and this produces H2O, NO2 positive, and HSO4. There. But in this case, we don't. In this case, we just react it with HNO3. Now, why is this the case? Because in this case, in case of phenol, the structure is like this. So there are lone pairs, and these lone pairs will become part of the delocalized region. We can say lone pair of electron is donated into the delocalized region. What happened to the density of electrons then in this region? Become more. We can say electron density increases, therefore electrophiles are attracted more with greater strength. Missed question. Okay, there's another question that we missed. Question. We'll go through this question. Done. What do we have here? We've got methyl benzene. It says reacts with sulfur trioxide SO3 to form D, shown below. The electrophile in this reaction is SO3. You just have to remember one thing here. It's going to be just the reaction of benzene ring. So substitution will take place. It does not matter what electrophile they give you. You should be able to do that. This is electron deficient. So the electrons will travel from here to here. At the same time, electrons will travel from here to here. And when this is going to happen, because it becomes O minus, so I can then say, then forms an intermediate. This, and it will be S double bond O dash O minus. What did I do wrong here, Mohan?
I'm not sure, sir.
Is it the ring? It's
The
supposed to
ring.
have
The
five
ring will
peaks.
have a
Horseshoes.
yes. It will horseshoe. So it will be this, and it will have a positive sign. Then what would happen?
It'll be like a H.
You need to restore the ring, right? The ring has to be restored. Plus there will be a H here. Then this H will give its electrons to this, and then you will get that, because you can see this hydrogen has been removed as positive. It's fine. Not difficult question. Question number 19. It says this question is about the hydrolysis of haloalkanes. When you do hydrolysis of haloalkanes, what do they change into? Mr. Z.
Was it just alkane? Or the
This is
alkane?
haloalkane.
Hello.
If you add water to it, what will it change into? Sana, what will it change into?
Change into alcohol.
Yeah, it will change into alcohol. So it says the rate of hydrolysis of haloalkane depends on the halogen present. So I can have different bonds, C dash Cl, C dash Br, C dash I. This one will be the weakest bond. Therefore, it will be the fastest. That's what they are going to ask you about. It says state and explain how halogen in haloalkane affects the rate of hydrolysis. So I can say C dash X. This bond strength depends on, will depend on haloalkane. And we can say C dash Cl will be strong, but C dash I will be weak. Therefore, this will be, rate will be higher in this case. And for this, I can say rate will be slow. Next one says cyclohexane is hydrolyzed with aqueous sodium hydroxide. With sodium, aqueous sodium hydroxide. What would happen if it was ethanolic NaOH? Then what would happen? Then will form, it will produce alkene. Remember that, right? This is very important. I've been asking you guys this for a lot of times. I've asked you this question in class. This is outline the mechanism for the reaction. So here I'll have a carbon. I can say this carbon will be delta plus, this will be delta minus. This is OH minus, will have a lone pair. This lone pair will attack here. This will take its electrons and it will then change into C.
So you have to name the mechanism.
So what kind of mechanism is it? It's substitution, number one. Yeah, it is nucleophilic substitution. Next question, I want you to put star on this, right? Because it took me a while to figure out the answer myself, right? So I struggled a lot on this question, but spent about 20 minutes just for these 4 marks. So it is an important question. Now I've highlighted what is it that needs to be considered. So here it says a student hydrolyzes a haloalkane E using the following method. He's got haloalkane and you reflux with excess NaOH to form reaction mixture containing product. So we can say it starts with haloalkane and you've added NaOH aqueous and you've done reflux. This then changes into alcohol. Plus, what else will it produce? Well, plus it will produce
NaCl.
NaX. We don't know what it is, right? It'll produce NaX. Then you add AgNO3. That's what it says. The reaction mixture is neutralized with dilute hydrochloric nitric acid. They're diluting it with nitric acid. They are adding nitric acid so that excess NaOH is removed. So it will produce salt and water, right? Okay. Excess AgNO3 is added to the reaction mixture. Now, what will it do? It will form AgX. And says this is 1.88 grams. They started with E. This is F and this is G. This is organic product F has a MR of 74.0 grams per mole. So here MR here of this alcohol, MR is equal to 74. Okay. Says draw a label diagram to show how the student would carry out the hydrolysis of haloalkane. You can have this, and we can then add you'll have that, right? You have to make sure this is water in. This is water out. This is the main thing that they are looking for. Do you know that which side will it go from? Now you also have to heat. So these arrows are showing heat. So this is all it carries. This is all that carries marks here. Condenser with water in, out, and they have to be bottom and above. Above is always out. Otherwise, if you start filling it from the top, you will never get filled up with water, because the moment water comes down, it will start coming out. So condenser will never be full of water, and it's not going to work in that case. Now, the next part says, so they've given us a bit of more information. We know from our own understanding, if you use 1 mole here, it will produce 1 mole of alcohol. And if it is 1 mole of alcohol, it will also produce 1 mole of AgX. Are we happy with that bit? This is coming from our understanding. I can't go through that bit now. But if you react 1 mole of haloalkane, it will produce 1 mole of alcohol. And then at the same time, it will also produce 1 mole of X minus. And these X minus will then produce 1 mole of AgX. Agreed? In this case, how many moles were used in the beginning? This is what I missed at the beginning, and that's why I couldn't work out. So I can say for G, I can say this is AgX. It is AgX. Now I can do here mass over mass times moles. Is that right?
Yeah.
And if I do that, that will give me the amount of MR. So if you do that, you'll end up with 0.01. That's my moles. Mass was 1.88. No, it's mass divided by moles. So if you do mass divided by moles, what would you get? So to find the MR of AgX, I'll do mass divided by moles, which will give me the value of MR. How much is that?
188.
Equals how much? 118. Now, if I take away, this is the
104.
104. It should be 188.
Oh, it's because you wrote 0.018. That's 0.01.
So this is 0.01, right? So in this case, to find the MR of AgX, I'll divide mass by moles. If I divide 1.88 by 0.01, it will give me an answer of 188. Is that right? 188. Okay. Now I can say this is, how much is AG? What's the MR of AG? AG is 107.9. I can do 107.9 plus X must be equal to 188. And it gives me X as 79, not 81 point. It gives, so if I do 107.9 plus X equals 188 and work out for X, it gives me 80.1. So if you go back and have a look at the periodic table, you'll see, therefore, this is B. Okay, done for the first one. Now the second part that we have to look at is about the alcohol. It does say here that the product has a chiral carbon. The product has a chiral carbon and it is 74 grams. So I can say the formula for the F will be CnH2n plus 1 and OH. But how many? I don't know the value of N, so I can say it will be 14N plus how much? 2N plus 1 plus 16 plus 1, and this must be equal to 74. If you solve, you'll end up with N being equal to 3, no, 4. Am I right? 74 take away 18 divided by 16. This is again, this is not 14N, this is 12N, sorry, because carbon is 12. So if I do 12N, that's for carbon, 2N, that's for hydrogen, plus 1, plus 16 for oxygen, 1 for hydrogen, equated to 64, you'll end up with the value of N as 4. So this means my formula for E is C4H9OH. But I must take into consideration this information. F has chiral carbon. So when I look at it, 1, 2, 3, 4. If I put OH here, then it will not have a chiral carbon. So it has to be at this location or this location. You can say OH here, and this has now got a chiral carbon. So I'm going to locate my, just show that this is my chiral carbon. It meets all my requirements. Now, because this alcohol has come from E, E will be exactly the same, but instead of OH, we'll have Br. So 1, 2, 3, 4. Is that the right thing what I've done?
No, I don't know. Is this supposed to be primary?
No, because this is same. They are both exactly the same. What I'm saying is, look, here it was on from the left side, I counted, and it was on the second carbon. From here, if I count from the left side, it's on the third carbon. But now I'll have to start my counting from the right side.
Yeah.
So they're both the same, right? So this is fine. This is fine. This is acceptable. I purposely did that. Okay. Just to check you guys. Okay. Let's move on to the other question. Number 17. Says the general formula for an alpha amino acid is RCN NH2COOH. It says the alpha amino acid R equals CH2SH shows optical isomerism. I don't know what they're trying to say here. Can you help me with this, Uzair?
What do you mean?
I don't know what are they trying to say by this.
The R group is the R group on the amino acid,
Yeah.
which is on the first or second carbon atom, consists of CH2.
Good, right? So they're basically saying that this R is this. Okay. I see the 3D structure show the optical isomerism. Optical isomerism. So for this, I can say, if I draw this one, it will become SH, CH2, CH, then NH2, and then COOH. So in other words, I can say this is chiral. Do people agree with this? Now I can draw it, right? So I can say it will be C, H. Here I can have CH2SN. Here I can have NH2, and here I can have COOH. Okay. Now it says I have to draw 3 diagrams, optical isomers. So optical isomers mean this is my mirror. Draw the same thing. See, the top will not change at all. This will now become NH2. This will then become CH2SN, and the other one will be hydrogen. Now this time R has now been changed again. Now we have a different R. We now have a different R. So I'm going to use the same notation. So I'll say on one side I have COOH, here I have NH2, here I have H, here I have now CH2 whole 4 NH2. That's my alpha amino acid. What does it react with? It reacts with dilute hydrochloric acid to form salt. So this is my base group. This is also my base group. This is my acid group. I can say this is acid group, this is base group, and this is also base group. But I add acid to it, and you know when ammonia reacts with acids, it will form salt, which is ammonium chloride, ammonium sulfate, and those. So in this case, it will then change into C dash. Nothing will happen to this, but the CH2 whole 4, this will become NH3 positive and Cl1 minus. At this location also it will become NH3 positive and Cl1 minus. Done? Easy question. Now this question, I was a bit confused and I don't know what to say, right? But let's have a look. Here it says you are doing now, the alpha amino acids can react to form protein. The short section of a protein chain is shown. So they've shown us the protein chain. What I'm now going to do in this case is I'll have to break it apart. So I am going to identify where are my linkages. Where are my linkages? So I can clearly see here, one of the linkage is over here. Okay, so you have to remember C double bond O will change into C double bond OH. Where it is NH, it will change into NH2. It'll break from here as well, because this is NH and there is a portion of it. It will also break from there too. So I can say here, it says a student hydrolysis the protein with hot NaOH. Draw the structure. They've used alkaline conditions. So you have to remember carboxylic acid will change into salt. Carboxylic acid will change into salt. It says draw the organic products formed. So when it breaks from here, I can say it will change into HO-CH2-CH-NH2-C double bond O-OH. Happy with that bit? The first one, this one. Now when this one will break, it will change into H2N-CH-C double bond O-OH CH2-CH2-C double bond O. What did we say? If you have a carboxylic acid, it will change into But there is more problem. It should not have been NH2 here. It should have been H then. Okay, but anyways, we are just sticking to what we are saying. So this section will remove from there. So it has to break from here as well. There's more problem here, right, which I'm not sure how to address. We can say it will change into OH. Now, what did I say here? Carboxylic acid will change into salt. It will change into salt. So wherever it is OH, I will have to change this one to O minus and Na positive. It will become O minus and Na positive. This will become O minus and Na positive. That's it. Now, a lot of people will miss out on this. So make sure you identify these kind of things like I have done. If it is alkaline condition, this is what will happen. Last structural question. This question talks about naming. So it says this question is about reactions of organic compound containing carbon, hydrogen, and oxygen. What do I have in this case? I've been given this is alcohol. How many carbons are there? 1, 2, 3, 4, and 5. Is that right? What I did, Mr. Ted? 5. There are 5, but this is not how you number them, right? I can't say this is 5 because this will be a methyl group. This is my longest chain. I have to go for the longest chain. The longest chain will have only 4. So on the third carbon, what would I say? On the third carbon, you have a methyl group. So it will become 3-methyl butane 2O. Now say structural formula, I'll say it will be CH3, C, H, and then CH3, and then CH2OH, CHOH, and then CH3.
Yeah, because you go the opposite way.
Yeah, it won't make any difference because then your numbering will start from the left side. That will be fine. Now it says the chemist heats alcohol A with acid catalyst to form a mixture containing 2 alkenes, acid and alkene. So if I draw this one for my own sake, I'm going to say 1, 2, 3, 4. Here I have CH3, and the rest is all hydrogens. Apart from the second one, I have OH. Now there are 2 possibilities, right? 2 alkenes. Double bond can appear here, and the double bond can appear on this side. If it is that side, then these 2 will be removed. If it is this side, then these 2 will be removed. Now it says draw the structure of 2 alkenes. So all I have to do is just copy them from there. 1, 2, 3, 4. The second one, there will be this 1, 2, 3, 4. Here, say H, 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 and that H, 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 and that. Now in exams, what they do is, I have always been doing this, right? But I don't think it's a good way of doing it, because if you draw the skeletal formula, then you will save a lot of time in exam. But you have to be very good at drawing skeletal formulas, because otherwise a lot of people will make mistake on that. Yes, Kazan, now go ahead, please.
So why is it not butane 2-ol?
Why is it not butane?
Yeah, no, like we should write AN as well.
You are right. Thank you.
Yeah.
I must have said it, but I never wrote it. But you're right, it's butane 2-ol. Now the next one says the chemist heats alcohol A with sodium chloride and sulfuric acid. Construct a balanced equation for this reaction. Show structures of organic compounds in your reaction. So what are we doing? We've got alcohol. We are adding sodium chloride and sulfuric acid. So if I go back to this diagram here, this is alcohol. Okay, if I add what did I say, sodium halide and H2SO4, and then it will change into halo alkane. It will change into halo alkane. Okay, so construct a balanced equation. All I have to do is it's going to be A is what? Plus NaCl plus H2SO4. A I can copy from the top. What will it change into? This will change into halo alkane. Plus what will it produce? NaHSO4 and water. So what is happening in this case is you have a weak salt. H2, which acid is more stronger? H2SO4 or HCl? HCl is stronger. How is it stronger? It has one hydrogen. H2SO4 has two hydrogens, so it's double. It's a diprotic acid, so it's more stronger. So if you have a salt of strong acid, then nothing will happen. But if you have a salt of weak acid, I had so many pages here a while ago and I can't find anyone. So this is what is happening first. When you have HCl and you add H2SO4, it's a rule, right? So you have here salt of weak acid. If you add strong acid to it, then what would happen? It will change into salt of strong acid plus weak acid. It will get recovered. So exactly same thing is happening. So when you have H2SO4 plus NaCl, it will form HSO4 and HSO4 from NaHSO4 because it is positive, this is negative, plus HCl. What is this? This is now recovered. Hydrochloric acid, because it was a weak acid, it has been recovered. Are you happy with that bit?
Yeah.
Now, you had, in this case, we never had haloalkane. What did we had? We had this, right? So this chlorine will come here. This and this will combine together and they will come out as H2O. Next part. I like this question as well, right? So, and this is what we say. You must do a lot of papers, because when you do a lot of papers, then they put things all together, like hybrid questions from different topics. Now, in this case, this question incorporates all three types of alcohols. I can see this is my primary alcohol, this is my secondary alcohol, and this is my tertiary alcohol. And you are oxidizing it. So if you oxidize, you know primary alcohol can be oxidized, secondary alcohols can be oxidized, but tertiary alcohols can't be oxidized. So they're testing on this with only 2 marks. When it comes to teaching this concept, it takes whole lesson, about 30 minutes, 45 minutes, but they're only testing you with 2 marks, so it's important, right? So we can see then this will change into agree, and this will change to double bond O and O. Now I'll have to add something. What is it that has been removed? 2 hydrogens from here, 2 hydrogens from here. So add 2 H2. Now, have added any oxygen? There were 2 oxygens used. 1 oxygen was added at this location. This is what has been. This has been added and this has been added. So in total, I've used 3. Next question says the flow chart below shows some reactions of compound C. Compound C. Now, what is compound C? Again, I see here. I'll first check. I told you this should be the common approach. you must always check which functional groups are present. In this case, it is alkene plus carboxylic acid. So here you are adding alcohol to it, and you're using. So this is my esterification. So I can say the same thing here. Double bond at this location, it will change into O-CH3. Here also O-CH3. That's my ester. Here I'm adding water. Now water will not do nothing to the acid, but the double bond, which is alkane, not alkane, alkene, will change into, look again, alkene will then change into, if you add steam H3PO4, it will change into alcohol. So I can then say, now again, one more thing. This is a symmetrical molecule. If it's a symmetrical molecule, it does not make any difference. No major or minor product. Only single product will be formed. So in this case, I can say it will be C-C 1, 2 OH. Did I miss one? It looks like I'm tired today. I am a little bit tired, to be honest with you. But mashallah, Uzair is very fresh today. I see he's participating as well. So the time he's spending in library is working out for him. Right? That's very good. Next one is polymerization. What I do in this case, repeating unit. The only thing that you'll do is you can put C-C. There will be two hydrogens. Here you'll have COH. Here you'll have COOH. You put this line and this line, and that's your answer. It's always good to start paper from the end, because then you are fresh. You all are fresh, and we can do harder questions while you are fresh, and then we can come to easier ones, and you feel more. Otherwise, as the difficulty level increases, you just say, oh, getting more difficult, let me just have a nap. So it's better to start from the end rather than be starting questions. Okay, so this is the end of all structured questions. Let's quickly have a look at the other multiple choice questions. Now, I'm not going to spend a lot of time on them. I'll just quickly go through with you. So on this question number 5, what we have here is, says which one is not planar. Not planar. So in this case, if I draw the structure of this will be this, right? So it is planar. It is planar. In this case, I'll have this. So it will have tetrahedral structure. So if it has tetrahedral structure around this carbon, there are 4 bonds. Around this carbon, there were 3, and there was no lone pair, so it will be planar. This one will be tetrahedral, so the answer is B. Next one says, what is the number of peaks in hydrogen NMR? Now, what I did is I started from the right side, and I looked at this first. So if you look at this molecule carefully, you will see okay. And what is this section? This section is agreed. So it's a symmetrical molecule, right? So I'll have one peak for this and this. Second peak will be for this and this. So it will have, how many peaks will it have? Hydrogen NMR. And then third peak will be for this hydrogen. So in total, it will have 3 peaks. Okay. Question 6. Wait, this is OH. So it will have 1 peak for this as well. This is OH, is not H. So it will not have 3 peaks, it will have 4 peaks. Okay. So just make correction there. It is not H, it is OH. That was bad understanding of the question. This is CHOH. Next question says ethanol can be prepared by different reactions. Which reaction has the lowest atom economy? You will do it yourself. There's a formula. Desired product mass over total times by 100. That's percentage economy. Just do it yourself, please. Now, question number 9. On question number 9, again, you will be given this sheet in exam, so make sure you make use of it. This sheet will be given to you. I can clearly see this is for alcohol. This one is for alcohol, 100% always, right? So I can see it does contain alcohol. So I can see it's not going to be this, it's not going to be that. If it was carboxylic acid, then this will be distorted at this location. But this is for alcohol, so it does contain. Now you can see this one contains alcohol, this one also contains alcohol. But this one, second one contains cyanide as well. So if I go here, it tells me for cyanide, there should be an absorption peak between 2,220 and between 2,260. And you can see here, there's a absorption peak. So this is for cyanide. So the answer will be B. Benzene reacts with organic reagents in the presence of halogen carrier to form phenyl ethanoate. Which organic reagent is required? What have they added here? Look, this is my organic reagent. So we'll have Cl because our halogen carrier is AlCl3.
3 of FeCl.
Yes. Next question says, how many straight chain structural isomers for this contain a chiral carbon atom? So what I did is it contains 7 carbons. I drew them all straight. If I draw on the first one chlorine, then it's not going to have chiral carbon. Here it will have a chiral carbon. It will have a chiral carbon here. If I put it here, then it cannot have a chiral carbon. Why? Because if I put it here, then the left and the right side will be exactly the same. If I put this and this, so these two are same. These two are same. So the only option is okay. Question 12, one of the very important questions, right? So make sure you put star on this as well. Good question. I liked it, right? Because there was a logic behind it that needs to be understood. Now, what is happening is they've given you the starting molecule here. So when you do NMR spectra of this, what will happen? Not NMR, the mass spectrometry. What will happen to this? It will break into fragments because it's a bigger molecule. Now, the fragments will be formed from this molecule. You can't have fragment from another molecule representing fragment of this molecule. So if I look at it, the first one here, can this fragment be produced from the top molecule? This fragment is not possible. Do you have any CH3 and then CO next to it? No, so this is not possible. Do you have this fragment? This is possible, right? Because you can see the CH3 hold 2 CH. If you look at the top one, do you have any of this? Can this be produced as fragment? It can't be produced as fragment. So these two are no, I'm going to say fragments can't be produced. Now there are only 2 options left. The first one and the last one. They are both possible. But if you work out the MR of this, MR here is 44. The MR of this one is 43. The peak is at what location?
43.
So the answer is C. See, it took only like 30 seconds to explain. But when I was working out, it took me about a good 10 minutes to work out why is this the answer, because it didn't make sense to me, a lot of things, right? And then I have to go back and realize, oh, I have to consider the starting material. So you guys are lucky because I can tell you these things, right? But no one is here next to me from whom I can ask. Next question says, which statement supports the delocalized model of structure of benzene? All carbon atoms have same bond length. That's true, because the ring is always, the electrons in the ring are rotating. Enthalpy change of hydrogenation of benzene is less exothermic than expected. That's true as well, because it's more stable. Bromine reacts with benzene less readily than with cyclohexene. Is that true or is it false? That's true as well. That's true, right? Because in cyclohexene, you have double bonds, and double bonds means greater charge density. In this case, the charge is rotating. So the answer in this case is A. You can make a note here, greater charge density. Due to double bond. Next question. A solid organic compound can be purified by recrystallization. Which statement about the recrystallization is true? The organic compound is more soluble in hot solvent. That's true. Whenever you have hot substance solvent, it's always more soluble. Hot solutions cooled before purified product or before the purified organic compound is collected. That's true as well. Last one says the melting point of purified organic compound is lower than the impure compound. That's wrong. Why? Because look, remember, in winter, what do? They put salt on the road. What does it do to the melting point? It lowers it. It lowers it. So the pure organic compound will have high MP and BP. Is it right? No. BP will be increased. If you add impurity, then the boiling point increases. Okay. We'll have high melting point.
And low, will it be low BP?
Wait, the melting point of pure organic.
The purified one will be it'll be easier to melt, I'm pretty sure.
The purified will be,
A lower melting point.
it will be difficult to melt because it will require more energy. Look, the temperature of the ice, when you put salt on the ice, what happens to it? It lowers so the original water ice has a higher melting point, but adding impurity will lower the melting point.
Is this only a reference to ice?
No, it's always. I'm just giving you example. So this is wrong. The only option that's true is B. Next one says, which of the following could react with compound below to form carbon-carbon bond? Carbon-carbon bond. What kind of compound is it? I've got, and I also have benzene ring. So benzene ring can react with other compounds. In this case, I can see CH3 can be added, right? So if CH3 gets added to benzene ring, they'll react together and it can form carbon-carbon bond. KCN in ethanol. KCN in ethanol.
I don't know.
Not sure.
Cyanide. Look, there are three things, 1 and 2 as well. So when you have KCN, this CN will replace. So if Br is replaced by this, then the bond will be formed. This is true as well. CH3OH and H2SO4. This is esterification. And in esterification, you don't form that. So only 1 and 2 are correct. So the answer is B. I skipped one question. No one told me. Question number 8. I didn't know the answer. We can have a look at it together quickly and then we finish, right? Question number 8, the answer is D. Okay, question 8, the answer is D. It says, which equation is propagation step in mechanism for this process? So in this case, look, NO will start with ozone, NO plus O3, and will form NO2 plus O2. Are we happy? Then NO2 will react with So what is happening here? This is regenerate, and then the same cycle will happen again and again, again and again, again and again, again and again. In reality, this should not be shown like this. It should be NO2 plus O3 and giving you NO plus 2O2. Has anyone got any question? If you don't, then I'll stop here. We'll do one more paper on P2 and then we just need to do one more P3, okay? Now, I do want to request people, please be on time, okay, so that we can finish our work, and then otherwise you will miss out. So please be on time next time. All right, then. You guys take care, inshallah. I'll see you all next week. Allah Hafiz. And I'll share the link for the recording with you people later, inshallah. Once I receive that the recording has been uploaded, and I'll share the link with you.
Sir,
Yes.